arrays, right? And it takes in a keyword called access, right? So this is the access along which the arrays will be joined. If the access is none, the arrays are flattened before use. Default is 0. Okay. Um, so it doesn't tell you what 0 is, but uh, first access by default. Okay, let's play around with it. I think if we play around with it, we'll understand. So let's first define some arrays, right? So you have A1, there's an array looks like this. And A2 is also a one-dimensional array, which looks like this. Now, this is a method, and inside this you have to give tuples, right? So you have to give tuples. So tuple inside the tuple, you'll give the arrays that you want to concatenate. So if I just give this, they're they're basically concatenated on uh, axis 0. So by default, the axis is 0, and 0th axis is basically your it's like a horizontal stack. So they're stacked side by side, right? So this was one array, and this was another array, and you can see in the output that they are basically placed next to each other, and then the borders are removed essentially. So that means that they are concatenated along axis 0. So this is axis equal to 0, and this is the default axis as well. Okay. Um, Now the same thing can be done with 2D arrays as well. So these two are 2D arrays. I could do the exact same thing again here, and okay. Um, so in this case, axis equal to 0 is taking the second dimension. So here you had only one dimension. So axis is equal to 0, basically merge them in that dimension. Here you have two dimensions, and axis is equal to 0 is going to merge them in the second dimension, right? So um, yeah, axis is equal to 0 is going to merge them in the second dimension, and axis is equal to 1 should go and merge them in the first dimension. It's a little confusing, isn't it? It is confusing. So here, personally, I don't use concatenate, although it is a method there. But I stick to vertical stack and horizontal stack because this can be confusing. Because when you give axis equal to 0 here, it is stacking them horizontally, right? So it is putting them side by side and then joining them. But here, in axis equal to 0, it is vertically stacking them. So essentially, it is putting them below uh, one another, right? And when I give axis equal to 1, then we are getting a horizontal stack. So it's different from stacking. It's just that axis is equal to 0, they'll be concatenated in the outermost dimension. Axis is equal to 1, uh, then you will go in, so then they'll go to the next dimension, like the next inner dimension, and then merge them there. So when I give access is equal to 0 for two-dimensional arrays, they were merged in the second dimension, which means that the one-dimensional arrays were concatenated and you got a single two-dimensional array. When I give access is equal to 1, they're merged in the uh, first dimension. So you only get two one-dimensional arrays now, right? And you obviously cannot give access is equal to 2 here, that is out of bounds. So you can either give access is equal to 0 or 1 for two-dimensional arrays. And for one-dimensional array, you can only give access is equal to 0, 1 is out of bounds. Okay, no, these are there. So now 1 is out of bounds. Only 0 is possible. Here you have two dimensions, so you can have two axes, 0 and 1. If you give access is equal to 0, they will be concatenated in the second dimension. If you give access is equal to 1, they will be concatenated in the first dimension. Right? And we can extend this logic to the third dimension also. We have A3, this is a three-dimensional array. So if I were to concatenate A3 to itself, A3 and A3, and if I give access is equal to 0, so now they will be concatenated in the third dimension, right? So they're concatenated in the third dimension, so you're seeing that A3 is present twice. If I give access is equal to 1, they will be concatenated in the second dimension. So now you're seeing that this was the first element of A3 and it has been concatenated to each other. This was the second element of A3 concatenated to each other. You can also give access equal to 2 here. Now they will be concatenated in the first dimension. Okay. Okay. So this is concatenation. Then you also have stack. Okay. So yeah, so these are my arrays. I can either vertically stack them or horizontally stack them. I could say np dot h stack, right? So h stack is horizontal stack, and I can give a1 and a2 here. So you can see that they have been horizontally stacked, which means that they have been put next to one another now. Similarly, there is another method called v stack, and this stands for vertical stack. Right, so now they have been stacked vertically, one below the other. Okay, and there is another method called d stack. It's for depth stack, and here you will see that uh, they are essentially. So what has happened is that they are now columns in a three. So this is a three-dimensional array now. This is not a two-dimensional array. So D stack is slightly complicated because it creates a three-dimensional array and then you essentially get columns. So this is now the depth. So the depth part of a three-dimensional array. So 1, 2, and 3 and 4, 5, and 6 represent the depth. Uh, Sorry, I'll be just back in 2 minutes. There's someone at the door. I have a parcel to pick up. Just give me 2 minutes. I'll be right back. Right, I'm sorry, I'm back. I'm sorry to keep you waiting once again. Uh, right, so we've seen horizontal stack, vertical stack, and depth stack. We've also seen concatenate. So these are two ways of joining your arrays essentially. Now, we've seen joining, and the converse of this is essentially um, flipping. So, um, so you have an array, one-dimensional array. Let's make a bigger array. Um, okay, let's say this is your array. What you can do is use this method called array split. Okay, then here you have to give your array and then you have to uh, give the number of splits. So let's say if I give two splits, it will create two arrays, right? So here this this is array number one that you get after splitting it, and this is array number two. You can also split it into three parts, and this is array number one, this is array number zero, um, and this is array number two. So I hope you get an idea there. Now, uh, if you give, so this was, it had six elements, which is, so six is divisible by three. But what if you give four? I think that should also work in this case. Just the last element will have, yeah, so the last two elements have only one, uh, last two arrays have only one element, while the first and the second array have two elements each, right? Um, Now, the same logic can be extended to a two-dimensional array, right? So, uh, anyways, so A2, this A2 is now a two-dimensional array, and the same logic can be extended to this as well. So I can do A2 dot rather NP dot array split, and we can divide A2 into two parts. So here you're getting two two-dimensional arrays. So here the array number one is also a two-dimensional array with just one element. Okay. Um, Now one more thing that you can do is with the axis here. If the axis is equal to 0 as default, uh, this is returning you. The split is now done on the outermost axis, which is, so basically your two-dimensional array is split on uh, the outermost dimension. So you're splitting these 1D arrays now. Now let's change the axis to 1 and see what happens. Now uh, the split is so basically now your rows are also split. So now these 1D arrays are getting split, right? So these arrays are now getting split. So you get, so this is split into 1 and 2, right? So this, it has been split like this now. So the axis of splitting has gone from like this, instead of being a horizontal axis on which you are splitting, it's now a vertical axis, right? So it's another, a different kind of a slice, if you will. It has been sliced like this. Okay, so you get 1, 3, 5 as one array, this left part as one array, and the right part as one array. So it's now a vertical slice, if you will. And if you give axis equal to 0, it's more of a horizontal slice. right? And you also have, just to make this a little less complicated, you have v split and h split also. So you have np dot v split, and here if you give a2, uh, yeah, number of splits that you want. You want two splits here. Array split does not result in an equal division. Number three. So this needs equal divisions apparently. So array split does not need equal divisions, but v split needs equal divisions. V split is vertically splitting, right? So it's the opposite of vertical stack. So if I were to take these three arrays, the one which v split has created, and if I would have vertically stacked them, I would have gotten back a2, right? And the opposite of h split is h stack is h split. So you have np dot h split also, and you can say that I want to split it into two parts horizontally, and this is the exact output that you are getting with this array split, and axis is equal to 1. This is h split, right? Alright, moving on to the next section here, which is basically searching. Alright, so you can basically look for values inside an array. So if you have a1 which looks like this, and if I say want to find out the index of this value 4, right? You want to find the index of the value 4, then you will use the method called where. First of all, let's see what happens when I do this. When I do this, a1 equal to 4, right? It gives back an array with true and false values. Okay, so anywhere, any index where the uh, value is true, uh, or the value is actually 4, right? So the index where the value is 4, that for that index, this array contains the value true. Everywhere else it is false. So you can use this to index the array. I think that is something that we've seen before, right? Right, we've seen this before. Indexing, conditional indexing, or haven't we? I just want to check that once. But have we looked at conditional indexing or not? I guess not. No, we have not seen conditional indexing. Okay. No problem. So let's look at conditional indexing first. So essentially, if I were to do this, right, or let's say if I were to do a1 uh, percent a1% 2 is equal to 0. If this is the condition that I'm writing, so you're seeing that for 2, 4, and 6, I'm getting true, right? Because these are divisible by 2 essentially, and that is the condition that I'm given. Now let's also see what happens when for a1 as an index I give a list of true and false. I give true uh, 6 elements, and let's make this false. Let's make this also false. So if I give a list of true and false here, basically acts as an index, right? So uh, the index for which the values are false are not returned. So 2 is not returned here, and also 4 is not returned because it's also false. So that means that I can give these conditions as an index because they also return a true or false binary array, right? So what I can do is if I write a1, and I say a1 is equal to 4, which is the condition, I'll be returned an array where the value is 4. Similarly, if I give the next condition here that a1 uh, uh, percent 2 is equal to 0, this is the condition that I'm giving here, then I'll be returned 2, 4 and 6. So this is called conditional indexing, right? Um, right. Searching is done using the where method, right? So you can say that um, so this is a1. So now instead of directly, so so now we are not giving this condition here as an index because we don't want the value. We don't want the value 4, but we want the index of the value, right? So so now to find the index of the value, we will use this method np.where, right? Uh, and now I'll say that a1 is equal to 4. So now this is my condition, and now what I'm getting back is this 3. So 3 essentially is giving me what? The index of the element 4 in this array. So it's 0, 1, 2, and 3. So this is now the index, right? And it works with two-dimensional arrays as well. So if this is a two-dimensional array, and if I do np dot where uh, a2 is equal to 4, now I'll get this weird output. Okay, so let's also check the shape here. The shape is 3 comma 2. So what I'm getting back here is essentially the index for the outer dimension, right? So the index for the outer dimension is 1, which is this, right? And the index for the inner dimension, which is also 1, so you get this. So this is the index, and it is returned like this as two arrays. Okay, so now if you want to use this information, right, to go back to the element to essentially extract this element now, if you want to use this information, so it will be slightly tricky because if you see that the index is a tuple of arrays. So if I do 0 here, I'll get this array back. I'll have to do 0 one more time. Now I'm getting back 1. So if I were to go and extract that element, I'll have to say this, then I'll have to say index 1 and 1. Sorry, index 0 and 1. No, my bad. 1 and 0. This. Yeah, this is right. And that is how I get back 4. Okay, so I change it to 5. That is how I get back 5. Okay, so this is how searching works. Now let's move on to the next topic, which is um, sorting. So yeah, there's a method for this is no rocket science. Let's create a new array for A1. Right. So there's a method called np.sort, and you can give A1 here. And you can see that the arrays are sorted. Now Now let's see what happens in a 2D array. So essentially sorting will happen only in the first dimension. Doesn't matter if your array is 10 dimensional or 9 dimensional or whatever, right? The sorting will only happen in the first dimension. So only scalars are sorted, right? So if I have A2, which looks like this, so because it seems like this 134 is smaller than 8, 9, 10, but their position is not going to change. Only the scalars are sorted, right? So the values in the one dimensional arrays are sorted. The rest of the structure is not changed at all. And the same holds true for 3, 4 dimensional arrays also. Okay. Working with arrays, uh, NumPy has a lot more to offer. To be honest, there is a module or a sub module in NumPy called random, which is something that you will uh, also end up using at some point of time in your life, right? Because it generates random numbers, it can randomly shuffle your arrays and so on, right? So we do end up using that as well. So I think because we have time, I can cover that part as well. But essentially, whatever you've done till now, uh, so if you're equipped with all of that knowledge, you should be able to deal with arrays at least, right? And that is the main purpose of NumPy, that you need to deal with arrays. Um, Let me quickly see if I'm missing something. If not, then um, yeah, actually, instead of going to random, we can look at some of the mathematical methods in NumPy. I think that's better. Let's look at some mathematical methods in Python, in NumPy, which basically, first of all, we look at a method that will update a single array, and then we look at methods of performing basically linear algebra operations with two arrays. So methods like addition, subtraction, dot product, cross product, and so on. Okay, so we can look at the NumPy methods. These are all inbuilt methods, and we'll also see that how to create a custom method, and then uh, yeah, how to use that custom method also. Yeah, I think that'd be better. Okay. So if we have an array called X, it could be an array or let's say an array, right, and then you have Y. So now it's just two X and Y because you're performing algebraic operations, right? So this is note that the shape is the same here, right? The one-dimensional array of the same shape. Then I can do np dot add. So this is the addition method. Uh, I can do np dot add x comma y. So you can see that it along the first dimension. So now um, there is also subtract method. So uh, subtract method is also there. Np dot subtract. Again, the shape should be the same, and I can give x. Let's give y and x. So if I give y and x, then x is subtracted from y. So you're getting 1, 1, 1, 1 because you can see that the difference here is 1, 1, 1, 1. Okay. Um, then you have element-wise multiplication. Then you have element-wise multiplication, right? So any element-wise multiplication can be done with multiply. So if I do np dot multiply,